Okay. So the main idea is uh, we need to find one point is observed by two cameras, and when this point is observed in the P prime, that's been our camera image, it's not enough. We need to take it from both sides to get the 3D measurement for a particular point in the world. So then we need to mark this from both images. To cut down the searching time, what we can do is we can take this patch and we can find the most similar ones, but it's not the exactly same one. The reason is we are looking at this point from two different angles. Now this is from a different one angle and this is from another angle. So we'll get a most similar one. It's not the exactly the same one. But this search space is big since it's a 2D image. But with the epipolar theory, what it says is for one particular point in the other domain, we get the epipolar line like this. So our search space, we don't have to search everywhere. So we just need to search only on this particular line. And we cut down our 2D search space by 1D. And this is the main idea. So we can go forward now from here. And you can see this is green. These are the two green screen, left and right cameras. And this is the point in the world. And we can make a triangle like this. And you can see it's a plane. It's kind of a it's not exactly orthogonal to these planes, but it's a plane. It's one kind of plane on the sideways connecting this particular point. Now we can make a equation for this plane. It says if you take a cross product of any of these two vectors, it could be any of these two. There are three vectors. Any of these two vectors, if you make a cross product, it is orthogonal to this plane. We discussed this on last time also, right? So that means, let's say we make a one cross product of these two, it is orthogonal 90 degrees to this plane. And when we multiply that orthogonal one with the remaining one, so we get 0. So this is what that equation is saying. So let's see exactly. OROL, this one, we take a cross product with OLP. These two, we take cross product of these two. Now this is orthogonal. Now we multiply with the remaining guy, ORP, then it is 0. This is our starting point. Now we know what to do with these cross products. This part of the cross product we can replace with something, but before going into that, we need to do something else. Shabish is joining. OLP vector, OLP, it is observed by the left camera. So how to move something from left camera to right camera?
Multiply with R into R, RL into RR transpose.
Yeah, we have a shortcut for that. We call it as R.
Yeah.
Yeah, it is RR, RL, transpose. Yes, but now we call it as R. Okay. So something on the left side, how to move it to right side? We simply multiply with R. Yeah. In the stereo camera system, we call it as R. So that's why this part we multiply with R to bring it to the left camera coordinates. Previously, it was in right camera coordinates. This one, it was in right camera coordinates. So we just previously actually everything was in right camera coordinates. So we move this one directly by multiplying with R. And the ORL, even if you look at from this angle or other angle, there is no difference, right? It's just a distance. So we can write it as same as it is without any changes. Okay. Up to now it's clear, right? We just bring only this one into the other one by multiplying R. Shabish, are you there? Shabish? His mic is mute, or maybe he's okay. So then the next part is this thing, our vector with the cross product. Can we do something for this? Last time we replaced this with something. What is this? ORL. It's a vector. X, Y, Z. It's a X, Y, Z vector. And what's the other one? Cross product and OLP. That is also vector, right? X, Y, Z. We said if there are two cross vectors and if there's a cross product in the middle, the first part, all across these, we can replace with the T matrix. You guys remember or no?
Yes.
Yeah, if you don't remember, I can just take our notes back, then we'll see the similarities. I guess it is lecture 2.8 or something. It's not lecture, it's my notes. Yeah.
Yes.
So in here, you can see the similar cases. Oh, okay, I can keep it like this here. In here also, this is a vector, and when we multiply these two, it's a vector. So that's why we represent it by alpha, beta, gamma. Because when we multiply matrix with the vector, 1 by 3, yeah, 3 by 1 vector, we get a vector. So these are two vectors multiplied with like with the cross product. Cross product to two vectors, we can replace the first vector and the cross product with the big matrix. Okay, this is what we did. In here also we can apply the same thing, right? Now you guys should be able to see the similarities. Nima, is it clear?
Yes.
Okay, so this entire part we can replace with the T matrix. And previously we had the column, row, and one. It was column, row, and one. Now we have X, Y, Z. So in the same places where the column is there, you can put X. Where the row is there, you can put Y. Where the Y is there, you can put Z. So this is how we construct this T matrix. Okay, but remember the position of these things. It's same like this. Okay. Is it clear?
Okay. Yes, clear.
Yeah.
The
Now,
same question he asked, right, in the exam?
could be because he asked us to remember where to put these positions. But always remember in the middle it's diagonal values it's 0. Then in
And
here
Yeah, the
also
same
minus
question
plus.
was there.
a negative one.
Yeah, you can see it's both are same. Okay.
Yes.
Like yeah, it's column, row, and one, and X.
Yeah, Z
Y.
will become 1, right?
Yeah. So you can see the top
In
element
orthogonal.
T. It is in here and here. First one in here also see it's same place. There is no difference. Okay, only the letter is changed. Okay, it's easy to remember. And this T, so we can replace this part with the T matrix, this T, and this is our previous R, and there is no cross product because we change everything with the T. And this T and R, T is 3 by 3, and what's the size of R? Sonu. Naveen is good with matrix.
3 by 3 only, right? Or
Yeah, R also 3 by 3.
this R.
It's 3 by 3.
Yes.
So now this
3
is 3 by 3 and this is 3 by C. What's the size of E?
E.
3 by
Yeah, it's
3
3
by
by 3.
3.
three
Yeah,
by
3 by
3
3.
by 3, same.
Yeah. So now we can summarize this equation. So this part, it as it is, and the middle part we can write it with E essential. We call it as essential matrix. Okay, and the last part OLP. Okay, and if you look at what are these in here, ORP and OLP. ORP and OLP. So it should be ORP and OLP. It is nothing but we are observing a point in the world from both of these cameras. Right?
Okay.
So you can see there are some similarities now. So you observe one point in the world from two cameras, and when you multiply these two with E matrix, we get 0.
Okay.
Okay. Now what happened is we get a relation between these two. When you observe point in the world from two cameras, you have one relation. That relation is the E matrix, essential matrix. Okay. Now what you can do is you can find one point and you can multiply with E matrix. Then you can find other one, right?
Yes. Yes.
Yeah.
Mm.
So the other one, in the sense, there's a small trick into that. But looking at the this equation, you may think, okay, if I give 1 point and when I multiply with the E matrix, so I get the other side point. So let's say, for example, in here, this is the right side point. I take the right measurement from the right side and multiply with E matrix. So according to the equation, it seems like we are getting the other side, right? Directly we are getting the point. But actually, we are not getting the point. We are getting the coefficient for this epipolar line. Coefficient, we get three values actually. When you give three values, x, y, z here, for the other side, you get A, B, C. Three values. Why? Because we said the theory says a point in one plane, you get epipolar line in the other side. So epipolar line is in what's the equation for a line? Ax plus by plus c
C is equal to 0.
equals 0. This is the equation for a line. So you get these coefficients. It's not the exact point you are getting. Don't get fooled by the values. It's not the point. It's a coefficient for this line. So we still need to, search across this line and find the point.
Okay.
Okay?
Hmm.
So you guys have the full understanding now, right?
Yes.
Yes, this is the entire thing. So now we are just, buttering up. Now, that's one more problem. This E matrix, it has everything in the meter coordinates. So this, because how we got E in here, it's with X, Y, Z. And X, Y, Z, we know it's in meter coordinates. And R also, R came from big R matrices. And these are, it's from world coordinates. And this is also in meter coordinates. So now the problem is, to do this calculation, we need to give this point, observe from this here in meter coordinates. That means we need to give the camera image in meter coordinates. It's difficult, right? We know we can measure the camera image in rows and columns. If we take a photo from this camera, the camera image we can measure in how many columns and rows, but how to measure it in meters, it's very difficult. So we need to convert this to columns and rows. Okay, that's what we are trying to do. Is it clear, guys?
Yes.
Our objective, yeah. Okay. So I will go back to the very first one again. In the very first time, we started with this pinhole camera. In here, you remember we try to get the relation between this pinhole camera. We said the ratio for this. This is the F you can see, and you can see the Z. F and Z ratio. F and Z ratio is same as Y and small y ratio. You guys remember this? Because this is the Y, small y, and this is the big Y.
Correct.
And this is, you can see F, and here to here it is Z. So, so this is correct, right? And I drew the same thing, the same triangle in here also. You can see this is I put X here, but actually it should be Y. And I can draw it like this: small x divided by big X. It's F divided by Z. So this is correct, right? You guys agree with me? I need yes or no.
Yes.
Okay.
Just mark cross multiply.
Okay. Nima, is it clear? You agree with me?
Yes, it's clear.
Okay. Okay. So we can take the small x out. So it is F divided by Z into X.
It's
Okay. Yeah. So what we can do is, the same equation, we don't do any big things yet. The same equation, other side is equal to 0. So I can multiply this equation in any value. So I can get a value called small a. So I can take a value called A, and I can multiply this matrix. And I can take a value called B, and I can multiply the matrix. Nothing happens this side. And other side, you get an A and B terms. So likewise, I multiply the whole matrix with one time, F divided by Z in R. And again, I will multiply the matrix F divided by Z left. Can I do it or not? I'm just multiplying. I can multiply, right? Because other side is 0. Okay? I need yes or no. Nima, is it clear?
Yep.
it's clear.
Okay, yeah, because this is kind of a general discussion, guy. I mean, so you also should participate. Okay. So now the thing is, look at here, f divided by z and some vector. You can see f divided by z and some vector, and this x also in capital X, capital Y, capital Z. Okay, and our what is OP? OP, the real image, distance to the real image, that is also in X, Y, Z. So what we wrote in here, it's the same thing in here. Both of these are same, right? And this is capital X. Yeah, because we are taking the point in the real world. It should be in capital X, capital Y, capital Z. So I can replace now this with small x, right? Okay, so I can replace this with a small x based on this equation. So this entire part is equal to this entire part, so I can replace with the small x. Okay, what is small x? Small x is, in the sense, that is the camera image. That is O prime P prime, right? Previously we measured the big world image, and now we are measuring this one, O prime P prime. So it's a camera image. The previous actually we measured from here to here. Why? Because the real point in the world, we had x, y, z 3 coordinates. We have the depth also. Why we are not measuring this P prime from O? Because P prime doesn't have a depth. The z, there is no z anymore. So that's why we need to measure it from O prime to P prime. So we get this equation now, camera image. So what we did was the real world point with the E matrix we convert into camera image. But this is still in meter coordinates, guys. Yeah. So now we are trying to go for the rows and columns. This is still meter coordinates. A point in one image is a line in other image. Okay, this is the epipolar theory. So now we want to remember, we should know the epipolar theory. All epipolar lines goes to epipole. Okay, this is I explained previous time also. So let's try to open the book. 280 something. To your image. Yeah. So this is the one point. I will use a different color. So this is the one point, and this point goes to epipole. For a single point, there's a line in the other domain. Change my page. So it's a line in the other domain. So let's say my P1, and I will make another point P2 and another point P3. So we'll try to find what are the epipolar lines for these. And all these lines goes through the epipole. This is for P1, P2, and P3. And all these lines go through the epipole. Okay, that's one center point. And how to find this center point? This center point is the one, it connects through these two axes of this OL and OR. And you can see it's punched through this green screen, and they create this epipolar. The point you punch the screen, that is the epipolar in here. And other screen epipolar is in here. Okay, that's clear?
Yeah, clear.
Okay, so we'll move back to here. So that's what's saying. All line goes through the epipole. The line connecting all cameras through the whole. Okay, this is the epipole, the same definition. Yeah. So there is one more thing. The matrix should be can be invertible if it doesn't have its eigenvalues 0. When we take SVD, so we get three values, U, S, V, and all the eigenvalues, it's sitting on S. And if one of these eigenvalues are 0, then it is not an invertible matrix. Okay, and it says in E matrix, one of its eigenvalues are 0, so we cannot invert E. It should be 0.
Okay. So it's not invertible.
Yeah, it's not invertible. E is not invertible. In fact, in the lab, what we do is we forcefully make it 0, one value. Because, the theory says it must be 0. So because of that, we forcefully make it 0 in the lab. Yeah, so it will be more clear when we do the lab. Um,
Mm.
this is we are trying to make the equation for epipole. What it's saying, you guys remember this? Yeah, I will just first show you what this is. OROL. OROL is the line connecting these here to here, and the second one is OL EL. That's mean the line connecting here to here. Okay, both of these are parallel, right? It's on the same direction. One vector is longer, other one is shorter. Okay.
Ah, yes.
What if you take the cross product of parallel vectors? What's the answer?
Will be 0.
It's 0. Yeah.
Yeah.
Naveen remembers. Okay. So the theory is if there are two vectors and parallel to each other, parallel in the sense it could be like this or it could be on top of each. Still it is parallel. And in here the case is one vector is long, other one is short. That's meaning one is on top of each other. So if that is the case, if you take the cross product, that is equal to 0. And this is our starting point. Okay, so now we try to get the equation for epipolar. This guy OLE, it is on the left side. So we need to move it to the right side camera system. So we multiply with R matrix. Okay, and so that is how we get this R. Then again, the same thing. Previously, what we did, the connecting vector. This is vector. It doesn't matter what is that, but it's a vector X, Y, Z. And we have the cross product. So we can replace entire thing with T. We just did it a couple of minutes ago. Okay, and we get the TR. And we know what is TR, that is E. So finally, we get this equation. Okay, so from this equation, we can find epipole. And why I'm saying OL, from OL we can find epipole. O is the center. Okay, and the distance to the epipole, when you take a point in real world or somewhere, you get three coordinates: X, Y, and Z. And what is X? How much is the width of the item? And how much Y is how much is the height of the item? And what is Z? How far the item is from me? Okay, the distance from you to the object. So when you know all of these three coordinates, okay, you know this object where it is. So you found epipole. Simply with this matrix, you can take the epipole. In other words,
But
when you have the image,
people is where everything converges, right?
everything goes through the epipole. I mean, the
Okay.
theory says if everything goes through epipole, so we should be able to see where the epipole is.
Everything means?
All the epipolar lines, all the dots in here,
Okay.
I made three dots. For all three dots, there should be epipolar line. So for the first dot, so I
Okay.
can draw one epipolar line.
Okay.
And second dot, I will make another epipolar line. And third dot, I will make another epipolar line. Okay. And all this epipolar line goes through epipole. Okay. So epipole is in here. And from this equation, we can find where the epipole is. Okay, there are two things, epipole and epipolar lines. Okay. Is it clear or you guys need any explanations?
Yeah, it's clear.
Okay. Naveen? Shabish?
Yeah.
I am not hearing from Shabish. Maybe he's sleeping.
No. I'm here.
Okay. He just woke up maybe. Okay.
I
Yeah.
have a doubt.
Okay. Nima, tell me.
Yeah. Now you consider three dot and the three epipolar line. Then
Yeah.
three epipolar lines origin is the same.
Yeah.
Like
Everything goes through this E point. That is epipole.
okay. Okay.
Yeah. So it's the center. So all the epipolar lines. So I will draw it again. So let's say, for example.
Then one more thing.
Uh-huh.
We have one point P. Then the P is observing the left and right camera. Then
Yeah.
when the epipole is created, the EL is created.
No, it's like this point is always there. Where is this point? but visually we can see this is the point. It goes through this. I mean, this is the line connecting OR and OL, and you can see these screens are tilted. So when these screens are tilted, when you draw a line, it goes through the middle of the screen and it will punch a hole in the screen.
Okay.
Because you know this OL point, it's a little bit behind the screen. So maybe the screen is there and the OL point is maybe 3 centimeters behind the screen. And here also 3 centimeters behind the screen. Think it as a 3D
Okay.
space. Okay, let's check Joseph's book. Maybe it's clear in his book. No, there is no difference. But you can see this vector, it goes through the screen. So this point is behind the screen. And the P point is in front of the screen. Think in that perspective. And now
Okay.
think, when you draw a line, and that line connects to both of these screens, and this line punches the screen somewhere, right?
Yes.
Go through the screen, and that point is our epipole. This is the visually how can we say? I mean, by drawing it, but mathematically we need to show it. But we need to find the point. That is what we did the calculation. That is
Okay. Okay.
E and our O L E E L actually O L E L equals 0. By solving this equation, we can find epipole. And the theory says all the epipolar line, it goes through here. Epipole.
Okay. Okay. Yeah.
And here, let's say, for example, your P prime is here. And let's make it as P1, P prime 1. And let's make another one, P prime 2. And let's make another one here, P prime 3. So let's draw the same thing in here. This is the P prime 1. And the second one should be somewhere around here. This is the reflection, okay? It is P prime 2. And the third one, we said it should be somewhere around down. Maybe somewhere around here. P prime 3. So based on the theory, the reflection image, it should be on epipolar line. So it should be in here. First one, this is, and the second one, it should be like this. It should cross the dot. Okay, your reflection should be on the epipolar line.
Okay.
Yeah. So and all these epipolar line goes to the epipole. And okay, I need to get the pencil. So when you search the, let's say for example, you know you want to search this P2 point on the screen. So when you want to search P2 point, don't search everywhere. Just search only
Only
across this line.
line.
Yeah. So
Okay.
you search. Okay, this is your most
Fine.
similar one. Yeah. This
Okay.
is how to do
Okay.
it.
Understood.
Yeah.
Yes. Yes.
But you can see
Yeah, got
now we reduce whole searching space to very small number.
Okay.
So that's why I said if the original image is 1024 and the height is 768, and let's say distance between here to here, this epipolar line, it's about 1000 pixels, right? Here it's around 1000 pixels. So let's do the comparison. If you search on the line, you are searching on 1000 spaces, 1000 pixels. And other
Yeah,
side,
that's understood.
yeah, can somebody multiply this 2D space? Sonu is lazy to multiply. 1024 by 768. Yeah, you can see it's a big number.
Yes.
786, 432. This many pixels you need to search in 2D space if you search. But in the epipolar line, if you use 1D space of epipolar line is a 1D space. So you can cut down the
to search only 1024.
Yeah.
Okay.
Yeah. Okay. So now I guess you guys understood that part. So we can go to the next one. So and we are trying to get the F matrix. F matrix is our friend in the sense when you use F matrix, you can do this calculation in rows and columns. Now, in the middle of that, we calculate how to get the epipole, but even with the E matrix. And here, what we did was, okay, we had the relationship now with the camera images, left camera image multiplied by E matrix, you get the right camera image. Okay, so let's see what we can do. So we said this is in the meter coordinates. So meter coordinates in the sense, okay. So how to convert meter coordinates into camera coordinates?
Meter coordinates.
In the camera image, intrinsic matrix, MI.
Multiply.
Yeah. So when you
Mm.
multiply, MI is created with two things, MA and MD. MA and MD. MA had focal length. MD had pixel sizes. We had the pixel sizes, column and row size of in millimeters, and that is how we created the MI matrix. So when we have the MI matrix, always remember if you have some camera image, it's a camera image by the way. When you have a camera image in meters, you directly multiply with MI to create rows and column coordinates. So it's like you have this P point in the word. First you multiply with ME matrix to get the camera coordinates, but it is still in camera coordinates, it's still in meters. To convert into rows and column, you multiply with MI matrix. Okay. Now here also, we set this point in meters and this point is in meters. So what we can do is we can multiply this with MI matrix. And you can see this is MI inverse. The reason is the above same equation is written in here. This is the above one same one. It's written in here. So O prime P prime, this is the camera image. If you multiply with MI matrix, you get the camera image in digital. This is digital, columns and rows coordinates. This is columns and rows. And that's what they mentioned in D, digital. Okay, that is confirmed, right? There's no doubt. Now, what you can do is you can multiply the whole thing, the whole equation, both sides with MI inverse. Okay, what happened when you multiply? I mean, you multiply with MI inverse. So you get MI inverse in here. And here what happens when you multiply with MI inverse? You get a 1. If you multiply matrix with its inverse, what happens? So no. So no, you are the one who wrote the math paper very recently. So when you multiply
I
a
didn't
matrix
get it.
with
Like if we multiply
no, you are multiplying.
matrix with its inverse.
Yeah.
Then it's 1.
Yeah. So this is what we did in here equation. O prime P prime. This side, so I can write it in my touchpad is not working today. Probably. Oh, right, guys. So this equation we multiply both sides with MI inverse. So we get MI inverse in here, and here it becomes 1. We multiply MI with MI inverse. Okay. And what we are trying to do, this whole part, this one, it will replace it here. And that's how we get this part. Is it clear? Okay. Yeah. Likewise, for the other side also, we can do the same. Okay. I didn't do it in here. And since this is transpose, and we get minus transpose. Okay. Since it is transpose, the MI matrix, it will not come from here. It comes from the other side. Okay. And now in the middle, we have two MI matrices for the right side and left side. And you can see one is transpose. Why it is? Because this side, this is transpose, and this is left side. And both of these, when we multiply all of these 3 matrices, remember this is 3 by 3, this is 3 by 3, 3 by 3, and we get another 3 by 3 matrix, that is F. We call it as F. But now this is in digital coordinates. This is in digital coordinates. That's been columns and rows. This is also columns and rows. And this is our final equation. Now, right side camera and left side camera in rows and column, we have one equation. So when you give right side camera coordinates in the left side, you will get the ABC values. Now, but we can use this equation for rows and columns. Is it clear?
Yes,
Okay.
these steps are using for the camera coordinate converting to the image.
Um, Not exactly. This is the same thing. Like the we make a relation between left and right camera. It's simply we made a relation between left and right camera. Previously we did it in here also, but this was in the world coordinates. Okay, and now we brought it to the camera coordinates. So we start from here, and we made a relation between left and right camera.
Okay.
Yeah, but it was on world the world coordinates, capital X, Y, Z, and here we made the same thing in camera image coordinates, camera image, but it is in meters. But here we finalize it with the meter, with the columns and row coordinates in the camera image. You can see P prime, O prime. When the prime comes, it's a camera image. In here, we made one equation to make the relation between both camera images. And when we multiply the first thing with this F matrix and the second one with F matrix, we get 0. That's mean given this side of the image, we can get the other side. Other side, we will not get the image, we will get epipolar line, because theory says for a point in one side, other side, we will get a line.
Mhm.
Okay.
Okay.
Yeah. So we can move to the next one. It's the same thing. Yeah. Let's see which one is. I think this is better because it has more details. And for the epipoles, we had this. We just finalized the equation for. I will delete one of these. Okay. For the epipoles, we had this equation in here: E multiplied with OE. But in here, we use the F matrix for the epipoles, and you can see digital coordinates because now we can get the epipoles in columns and rows. Previously, we can get the epipole in meter coordinates. So we prefer to use the F matrix. Why? In the F matrix, we get the things in columns and rows. Okay. So we prefer to use F matrix. But there was one exam question with the E matrix also. And this is for the left side camera, and this is for the right side camera. And when the right side camera comes, we have this transpose. Okay. And now how to find this the epipole? If we get this F, and we can use SVD and the last column of and again this is like F is a big matrix, 3 by 3 matrix, and this is a vector. CE is a vector. It has column, row, and one coordinates equals 0. We can use SVD. So we can use SVD to solve this and get the V. Okay, this is how we find epipole. If we know F, we can find epipole with this SVD. Okay, this is how to solve it.
Okay.
But still, we need to find find F. Okay, because in the now what we do is we go all the steps from top to bottom, and we'll stop in F. And in the lab, what we will do, we'll get some coordinates in the world our camera images, and we'll put it into the F. What we'll do from both cameras, we will observe some points and put it into F, and we go back and construct all other calculations from bottom to top. Okay. Um, but before going into these details, I like to tell you guys how to construct this F. Yeah, we can start from here. So we had this equation before. Same thing. It's the same equation. You guys familiar with this one, right? We just finalize on the last page and point in right side camera image multiply with f, and we get the side camera image. So other than writing CP, I can just represent it with the P, because this is one point, right? Other side also it's not a point other side, it's a coefficients, by the way. Okay, and I can write it with CR1 for this point, and for the f, these are the f values, these are the unknown values, unknown 9 values, and other one also I can write it like this. Then I can expand this matrix multiply with this, then that combination I can multiply with this, then I get a big equation like this. Okay. Now our objective is to find these f values. Okay. There are how many f values are there?
3 by 3.
Yeah, 9
Nine.
values. Okay. How many equations do I need?
Mm.
9 equations.
Mm.
Okay. I guess Nima answered this one correctly in the exam question.
Mhm.
So,
Maybe I randomly.
What was the question?
on the last day, there was an exam question. It asked how many equations we need, how many points we need, or something.
Ah, yeah, I
Okay,
remember.
yeah.
I remember. Ah, yeah,
Yeah.
9.
You
Yes.
answered 9.
Ah,
but
yeah,
I
yeah.
answered there is nothing like that.
Oh, it's entirely wrong. But I answered 7. The reason is why I answered 7.
But previous class Gayan said the theoretically they need 9 equations. That's why I'm clicking 9.
Eight.
Yeah.
Eight
Yeah.
unit.
Yeah.
Minimum.
The reason is, usually it is 9. Usually, yeah, if there are 9 unknown values, you need to have 9 equations. But the theory says one of these eigenvalues are 0. So when you take SVD, the middle part, SVD, the S part, one of these eigenvalues are 0. So we have, because of that, the one of these eigenvalues are 0 constraint. If we have 8 equations, we can solve it.
Mm.
But I will not confuse you guys. But Joseph said, even if you have 7 points, we can verify it. We cannot solve it. We can verify it. So, but that's why I make mark as 7 in the exam question. In the exam question, there wasn't 8. So the 7 was there, 9 was there, some other values are there. But 7, it's not the correct answer. You can only verify. But if you have 8 and 9, you can either select 8 and 9, both are correct. But if it asks what's the minimum, how many points you need minimum, it is 8. It is
Okay.
only for this F. Okay. For the previous one, BM equal 0 and AP equal 0. No, you need to match how many values you need. But in this case, it's a little bit different.
Mm.
Ah, okay.
Yeah. Remember, just remember for 2 days. Tomorrow and day after tomorrow. After the exam,
Yeah. One doubt is that we found E is the essential matrix, right?
yeah, E is the essential matrix. And from
So
E,
what is the fundamental matrix?
Yes.
F is a fundamental matrix.
Okay,
Then
F is the
I
fundamental.
have one question.
Mhm.
E is the essential matrix. Then what is the we have one question, right? The case of fundamental matrix, what is the exact steps of first we have to find the points and SVD, then next something the matrix multiplication or something like that. So in the case of essential matrix, what is the three simple steps for the essential matrix?
For the fundamental matrix, okay, we'll go into here and we will answer that question. Just repeat the
Okay.
question when we reach here, because we are almost there. Because we need
Okay.
to have this part to answer that. Okay. So now
Hmm.
we said we need to have 8 equations. So this is one equation. Okay. And this is for one particular. I mean, this is for 2 points. You can see this is 1 point and this is another point. Okay. And previously I said, when we use this equation and when you give a point, other side, it's not a point, you get ABC values, and that is the coefficient for this AX plus BY plus C equals 0, right? Then why I wrote column, row, and 1. The reason is So, okay, in here, I will draw it again. For one particular point in here, other side we will get a line. Okay, but if you take a point in here, one point in here, that point also valid. It's a one candidate on this line, right? So if I manually pick a one point in this here, I will pick a point. But if I pick a point in here also, this should be true. Any point in this in here, the equation becomes 0. So that's why I can pick a point in the other side also to solve this issue. Okay. Is it clear, or do I need to make any explanations?
No.
Okay.
Clear.
Yeah. Okay. So from the now how to solve f? We'll take a point in the right camera and exact point we'll observe, and we'll find it on the left camera also. Then we'll make an equation. So you can see for a one point, sorry, for a one equation, we need to have 2 points, one in each camera. Okay. And since there are minimum values are 8, how many points I need to click?
8.
8,
Think again.
16.
9.
16. Yeah, it's 16.
16.
Oh.
Because you know,
Yes, yes.
we got this equation by clicking a point on left camera and right camera. There are 2 points. From 2 points, you got one
Okay.
equation. Now we need 8 equations. Okay, it's 16 points.
Okay.
Yeah. So don't by heart, just remember the theory, then yeah, you will understand. Now, can you guys see the screen? This is the maximum I can. Can you guys see?
Yes.
Okay. Now the thing is, this equation we can represent it by 2 matrix multiplication. We did before also. All the f values we can mention as a long vector, and the c and r values we can mention like this. And we'll just multiply it and see whether we can create this equation. And why we need to do it like this way? And this is linear, and this is not linear. So if it is not linear, computationally it's not efficient. So and our teacher Joseph Pigan, he doesn't like it. Okay, so we'll multiply this and see this value multiply with f11. Okay, we get this candidate, and this one multiply with this f12, cr f12. Okay, we get that, and cr multiply with f13. Okay, cr f13. Likewise, we get the same exact one. Okay. Now one of these it's transpose, and this one is transpose. That's why it's qtf equals 0. Why it is small f? So no, tell me why it is small f for the capital F. So
No, it is smaller.
because capital F it's a matrix, and this is a long vector. We just transpose. I mean, we just
Okay.
translate it to a long vector. It's the same thing, same values, but it's a vector. That's why we represent it by small f. And this is for 2 points. Okay, one from right camera, other one is from left camera. Column, row, coordinates are there. And for many points, we need to create a big matrix, one after another, right? We'll put a 1 point, 2 point like this. We need to put all the things, and we create this big matrix, Q matrix. Okay. Now we said bare minimum we need to have 8 equations. So for that we need to click 16 points. So we'll click 16 points. When you click 16 point, this is for 2 points. We get 8 lines like this, 8 rows. Okay, and we get a big matrix. And to get
That's why the small q will the big Q.
no, there are multiple copies of this. This is for point
Okay.
1
Then
in left right camera.
what is the small q?
Okay, you can see this equation.
Yes.
Yeah, the same equation we can write it as 2 matrix multiplication.
Okay. Then again the downside, that is a alphabet, the capital Q.
Okay, so forget about this for a moment. And
Mhm.
is this both of these are the same?
Okay.
Yes or no?
Yes. Yeah.
Yeah. Okay, that is same, right? Okay, so we can.
Yeah. Same.
Okay, now let's say, for example, this is for how many? I mean, you have one equation. This is for
Hmm.
2 points. Okay, and this is also
Okay.
this Q that is for 2 points. And to
Okay.
solve this equation, we need to write this for 16 points.
Hmm.
So this is first 2 points, and this is for another 2 points, and another 2 points. Like this, we can create a big Q matrix
Hmm.
by stacking all the points. So that is how we create the Q matrix.
Oh.
Because the
Okay.
simple requirement is we need to have 8 equations.
Okay.
You got it?
I understood.
Yeah. So we need to have eight equations. When you write it like this, yeah, we get a one equation because it's the same thing. When you multiply, you get the same exact values. So what we do
Hmm.
is this part is not changing. Whenever we increase no new equation, only this part is repeating. So we stack them on top of each other.
Okay. Nice. Very okay.
But every row, it's for different point.
Hmm.
Okay. You can see it's, by the way, right and left. It's two. It's sort of a single point. It's a pair of points. See, right point, left point, like that, corresponding one.
Hmm.
So now is it clear, the Q matrix?
Yeah. Clear.
Okay. And now we have Q big matrix. F is a vector, and other side is 0. We call this as homogeneous equation. How to solve this?
Let's see.
SVD.
SVD. SVD. Big matrix, small vector, long vector, equal to 0. Yeah, solve it with SVD.
Hmm.
Okay. So we use
Yes.
SVD, and last column, we have 12 unknown values. It's not 12. How many unknown values?
6.
9 unknown values, right?
9.
Yeah, it's not
9.
12. I made a mistake. It should be, yeah, it's 9. It's 9 values. Okay. So last and we get 9 values. And one more
Hmm.
thing, we said this F, one of its eigenvalues are 0. Because of that, it's not invertible. You remember I said it before? They said the theory says the F is not invertible. Okay, we cannot invert. No, we cannot do it because one of its eigenvalues are 0. And
Yeah.
where the eigenvalues are sitting in SVD?
S in S.
In S. Okay, and when you take the eigenvalues, so eigenvalues arrange in a way, and the last smallest one, it's sitting in the down. So the 0 one, it should be this one, right?
Yeah.
So what we do is we forcefully make it 0. If it is not 0, we'll make it 0. Okay. Now we have our new S. So we'll make it as S tilde, and we have our U, and we have our V. So we multiply these matrices again together to construct our Q, new Q.
Hmm.
So what we do is we take SVD, okay? Because of that theory says the F matrix is not invertible and one of its eigenvalues should be 0. So we make it 0 by forceful. Then we multiply these matrices again, and we make Q. Okay. Then again we go and take the SVD of Q to get the correct V. So we get U SV values again. Then we take the V again. This is our F.
Hmm.
We do it 2 times.
Okay.
Okay. Is it clear, you guys?
Yes.
Okay.
Got it.
So there's one more part in here. Before come to that part, I will jump back to the lab, and we can do a one part.
And this Q is the matrix we created by taking the points, right?
Yes, exactly.
Okay. So is there a name for that Q matrix?
No, as far as I know there's no name, because this is just a, it's not a we just make it to do the calculation easily.
Hmm.
We just arrange the things in the So in the Q matrix, what we need to do is we need to arrange the values like this. But you can do it in the easy way. You can create two vectors like Q1 and Q2, and you can arrange the right vectors column, row, 1, 1, 1, and other side is left side column row 1, column row 1, column row 1. And when you take the point-wise multiplication of these, you get this guy. And this is the one we need because in the lab, we can directly construct this one. We can directly put it one value after another, and we can construct it. It's a one way. But easier way is we can construct these two small matrices and multiply. It's just like, it's too much for the brain, but this is what Joseph has done in the lab. Okay. So I'll just start the lab. Mm. Okay, this is lab, last lab, right? Epipolar. So I will just run this one time. And there's one program in here. So I'll trending in here. And this program allow us to take the point from both sides. So I uncomment this part and I will save it and I will run it up to here. So this part, what it will do, it will allow us to take points from left and right. Because first thing is we need to pick the points on left and right, columns and rows, and then we need to construct the Q matrix.
Okay.
So you guys remember what we did in here? So we need to construct this Q matrix. To construct the Q matrix, we need the points in left image and right image, right and left, columns and row, like that. Okay. So this program allows us to take from both sides. So let me keep this side by side. This is left, right image. Okay. And I will run it now. So now I need to pick and take the points, but it should be the same thing. I need to click on the other side also. Okay, you guys got it? So I can take one point in here.
Same point here to take in another picture also.
Yeah, and left camera and other side also we need to take in the same one. The mathematically, when you take these points, the right side point multiply with F matrix, multiply with the left side point, it should be equal to 0. Okay.
Okay.
And but in this program, the bare minimum we need to take these kind of 8 pairs for the bare minimum, but we take 14 points, 14 or 15 in this lab to reduce the error. We can take more points. I guess we are taking n points. You can see some variable. Yeah, 15 points. We need 8, but we are taking 15. So like this. 2, 3, 3. So this is the A for box. 4, 4. This is my 5th point. There is nothing says that I need to click on these edges. I'm just doing it because I can easily track it.
Oh, yes, this is.
So I can click somewhere in here also. There is no problem. But the thing is, I have a hard time to identify the same point in that case, right?
Mhm.
6, 6, and here it is 7, 7. Oh, 6, 8, 8, 9, 9, 10, 10, 11, 11, 12, 12, 13, 13. Where can I click? I can click here. 14, 14. So now tell me one point, please. I'm running out of points.
Maybe the down point in that
Maybe I can
box.
click here.
Okay.
The same one should be. Yeah. Okay. My program exit. Now I should be able to see these values. Oh, how can I see these values? Maybe all of these values are in a variable. Let's see this program. Yeah, one PR and one PL. These are the variables. No, I guess these values are appending to somewhere. Yeah, I think it's a text. Yeah, PR and PL. Okay. So it is PR and PL. Okay. So we got these points in PR and PL, these two variables. Okay. And he already gave the points, but we can use our points also. There is no issue. So so I will comment this part of the program. So, okay, R and P. These two also I will comment it. So we will use our points. Points we took. PR and PL. So we'll first use PL. And all our PL points are in here and with homogeneous coordinates. So we'll just copy the points. Like this. Let's import this in Swedish. PR. But you guys understood what we are doing here? Say it
Yes.
out. Fully
Yeah.
got it, right?
Yes.
Yeah. Okay. So I put the values. Now I can run the program to here. Then it will display these points. So up to here, I will directly stop the program and I will run it again. So now we will be able to see these points. Okay, we will go step by step. Oh no, it's in here. It's to continue. Okay, these are the points we had. Okay, it already finishes. Okay. So what I need to stop in here. For some reason, it's not stopping. Oh no, this is inside the program. So we will not use this normalize. Okay. The end of the program. Yeah. So we are in here. And now we try to construct this Q matrix, big Q matrix. In here, PR had it's same as the PR in the right point. Okay. In the right, so in the right point PR, you can see first column is columns, and the second column it is rows, and the third one it is homogeneous coordinates. So in here, this is our columns, okay, and this is our rows, and this is the homogeneous coordinates, okay. And in the MATLAB, so this is how to select the first column, all rows and first column. That's mean we are selecting the columns, and here we are selecting the rows. The second column actually, second column of the matrix. That's mean all rows, okay. And we construct our queue. Here these two lines, it's doing that mathematical trick I told you. It's just one shortcut, but there's nothing important in here. So in here, other than this constructing the queue like this long way, we can take small two vectors and multiply, and we can construct this one. It is easier. So it's just one small trick only. I don't think you have to remember that. It's how the program is written. Because a program we can write in different ways, right? So the basic idea is now we constructed our queue. So we took the points and we rearranged the values and we constructed our queue. The queue is nothing but columns and row values. Okay, guys, is it understood?
Yes.
Okay.
Yes.
Now what we need to do? Sonu, or somebody can you tell me what's the next step now?
Find S.
Find
F1.
SVD. Okay, SVD, and we need to correct the S value.
Yes.
And construct the queue again, then take the SVD again.
Yes.
Because this step we do it 2 times because we need to correct this. So first time we take the SVD. Here we are making it 0. Okay. Here we are making it 0. Okay. So I will go step by step. We take the SVD. I take my mouse point. So we can see this is our Q matrix. So it's a 9 by 9 matrix. And usually we take the last column. Okay, but there is no guarantee because you know the S value, last eigenvalue should be 0. And it says we don't know actually because we need to multiply this with 1000. So we can do one thing. We can just write S here and we can see the values. Yeah, it looks like it's 0. Yeah, it's 0. But so because we took the points in a very good way, so that's why it's 0. But we can make it 0. So this is, I mean, if it is not 0, there's a big problem. So that's why we make it 0 in this step. Okay. So just for a moment, don't think about middle steps, and we will skip these steps. This one and this one we'll skip, and we'll come back to that again later. So what we do is we construct the F again by multiplying. Sorry guys, just a moment. Yeah, there's one more thing. Okay, I guess I'm. So we take the SVD of Q. Okay. then the theory says F has a one eigenvalue is 0. F has one eigenvalue. So we will not take this guy's eigenvalue to 0. So we need to take the SVD of F again. So I will need to draw it. Yeah. I made a small mistake. So we take the SVD of Q, okay, and the last column, that is F matrix, okay, it's a F vector. Okay, is it clear? We take the SVD of Q and we get a V. V is a 9 by 9 matrix, and the last column of V, that is our small f. And we already know how to construct this into F matrix. We just need to rearrange the values. Yesterday we did it. Then the theory says, then only we need to apply theory. The theory says one of its eigenvalue should be 0. The smallest eigenvalue should be 0. So how to check the eigenvalue? We need to check the SVD of F. So we need to take the SVD of F again. Then we get USV values. And here, the last eigenvalue, it should be 0. So what we do is, we set this value manually to 0. And we construct USV multiply with USV. We create the F again. This is tilde. Okay. Guys, you got it?
Yes.
Yes.
Yeah. Previously, the mistake what I had was, I asked you to take this guy's as 0. No, it's not. You need to take the SVD again. SVD of F. Okay. Is it confused, or you guys can catch it up? So we take SVD 2 times. First time we take the SVD of Q and we take the F output. So I'll draw it like this. So first time we take the SVD, that is for Q. Okay. Then we construct our F matrix. Then we take the SVD again. This is for the second time. Then we make the correction and we construct by multiplying with U, UF, VF, US, UF, SF, VF. This is what we do. So I'll clear the board. So if we look at lab, we took the SVD of Q, and the last column, it's a F vector. Okay. So we take the SVD of the last column of V, that is our small f. Then we need to rearrange these values, and we create a capital F, this matrix. But the theory says when we take the SVD of F, the last value should be 0. Yeah, it is 0 right now. The last eigenvalue should be 0. It is 0 right now. But to make sure, we make it 0, because there could be some chances it is not 0. So usually when we take SVD, we write the values as USV. So in here, we just wrote it as UF, VF, SF, and VF. It's just a variable name. So we take this is the SF tilde. That's mean the new modified value. So we are making it 0, the last value. Third column, third row. SF has only 3 columns and 3 rows. So the last value, we are making it 0 by forcefully. And multiplying these 3 values again, we construct our F, UF. But you can take SVD of whatever the matrix, and you get the values. In here, we had US, UF, SF, and VF. And when you reconstruct it, so you need to take transpose of this guy. I guess we already discussed this. Because mathematically, when you take the SVD of some value, you should get U sigma V, V transpose. But in the MATLAB, it will give you SV. It will remove the transpose and give you. So that's why you need to multiply. I mean, you need to take transpose of the last guy. Okay. So you got it? Sonu? Sonu sleeping. Naveen, is it clear or is it confused?
Yeah.
Okay.
It's clear.
Yeah. So we came up to here. Now we already found F. Let's see what we are doing now. Normalize part no need because we did normalize. Okay. So now we try to draw the epipolar line for a given point. Okay, now we have the F matrix. So if we have the F matrix, so I'll come to the maths part again. Now we calculate the F matrix. So to get the F matrix, remember guys, you need to do the SVD 2 times. So first, directly by taking here, we can take the F matrix, but we need to make the correction. That's why we take this the SVD again and reconstruct it. Okay. Now wait, why we take SVD 2 times?
For changing, for reconstruct.
No, you need to explain properly.
Yeah.
Nima, why we take SVD 2 times?
For the reconstruction.
For
So
small.
why we take for the first time? Why we take for the first time?
For finding the unknown values.
Yeah, to find the F, initial F, to find the unknown
Yes.
values.
Yeah.
Unknown values are what? Our F. Okay. But
F.
we need to make a small correction in here because it says the last eigenvalue should be 0. So that's why when we find F, we are not guaranteed it is the correct F. So we take the SVD of this F again, and we reset the eigenvalue and we reconstruct. Okay. Yeah. So I need to come and show you one equation. Okay, look at this equation. So this equation, what it says, if you give a point, check the lab. Okay, in the lab, as of the first part, we give a point in the right side. If you give a point in right side and multiply with F matrix, what you get in here? Point or coefficients.
If you give
you are giving a point,
then coefficient of line.
Yeah, because for a point, you get epipolar line.
Right.
So you get 3 values, but don't get fooled by these 3 values. It's not a point. It's a coefficient of ax plus by plus c equals 0.
Okay.
But what is your x in our case? We have image, long image. How to draw image? How to draw line in here? Now we need to draw some kind of line in here. So this is your x-axis, right? That it's in the sense how many columns you have. How many? That's mean the pixels in the x-axis. You have 0 pixels, 2 pixels, 3 pixels, 4 pixels, like that. Sonu, hey Sonu, Sonu is sleeping. That is guaranteed. Yeah, his mic also not mute. He's not mute. Yeah.
I know.
Yeah, he's sleeping. Okay. Not even 12 o'clock. Okay. So guys, now the thing is, you saw this image. I will show you again. In these images, the size of the image, 756. This is the width of the image. Okay. And that is your X. So you have columns up to 756, right?
Yeah, 16.
768. 768 values from 0 to 768. So what I'm doing, 0 to 768 values, and that is your X. All value ranging from here, that is your X. So you need to get your Y for these points. That means you need to take Y into one side, and you need to write this equation. Then you take all other things into the other side. That's mean by equal minus ax plus C, right? Then I need to divide everything by B. So it becomes A divided by B x plus C divided by B, right?
Yeah.
So now this is our equation. So we give all the values from 0 to 768. So we get y values. Then we can draw a line. Okay. So I'll just keep it in the screen. And I'll try to move this because the last guy, the only important thing, this is we agreed. So I'll delete the rest of the things. Okay. Now to draw a line, first thing, I take a one point and multiply with the F matrix. I take a point in the right side. Remember this, I take a point in the right side. The direction matters. If I take a point in right side, I need to multiply with the F matrix on this side.
Okay.
If I take a point in the left side, I need to multiply with this side, particular side, right side of the matrix. If I take a point in right side, I need to multiply with left side. Okay. Remember this. Oh, okay. Control Y. Do you guys know how to do a redo? Oh yeah, okay. Done. So we'll go back. So we take a one point. This is the one point in matrix. So I can just show you. It's just a one point. We just take the first point. Okay. And we get the column, row, and homogeneous coordinates. Then I multiply with our F matrix. This is our newly constructed F matrix. See, it's a F matrix. And when you multiply, you get this ABC coefficients. So these are the three values. You can see it's not a point. The last value is not 1. It's not a point. It's a homogeneous coordinates. It's not homogeneous coordinates. It's a coefficients. Okay. Now we need to put into this equation. So that's mean what is B? So we got the equation as AX plus BY plus C equals 0. This is the first value you get, and this is the second value you get, and this is the third value you get. And that is your values. When you see your ABC, the second value, we need to divide all the rest of the value with second value, right? That is your B, because you know this is your B. So that is what we did in here. We divide ABC with second value. Got it?
Yes.
Yeah. So we construct our Y, then we multiply X with that, and the third one with that. So we get our Y. Then we can draw a line. We can plot a line by giving X and Y. That is what we do here. Yeah. Now we'll see. We took a point on the right image. You can see the right in here, right image. We took the, I'll delete everything. We took the point number 1, and other side, it's a line, but that line should go to our point number 1 in the other side. So, yeah, we take a one point, and if we search across this line, okay, our candidate is sitting on that line somewhere. See?
Oh, yeah.
Yeah. So that is what we did in the lab. And we can take a one more point. This is point number 2. And we'll see for the point number 2 also. And we can see the point number 2 in here. And we get a line. And when we search across that line, okay, our second candidate is sitting on that line somewhere.
Okay.
Yeah. And the third one also, yeah. Third one also like that. And third one also like that. But next one will be different. Yeah, our third point. Okay, I took my third point in here. Yeah, it's sitting in here.
Okay.
Okay. So the next one is, it's a little different. Why we take a point in the left side now? not in the right side, we take a point in left side.
Okay.
Okay. Now, earlier, we multiply the value on the left side. If you take a right point, it should be in left side. Now we take point in left side, so it should be in the right side.
Okay.
Yeah, and we take transpose also.
Okay, for the left side.
Yeah.
Okay.
Not for the left side, because when you multiply, the answer should be transpose. It is okay. You give a point on left side. Okay, that's not transpose. You just take a point in
Right
left side and multiply with this, and your answer it is
Answer.
transpose.
Okay.
So, so I will go forward. So, but we take the point in the other direction now, and we took the point on left side. Our point is point number 5. Okay, we'll go and see. We took the point number 5 on the left image. Point number 5. Yeah, it is this point. So other side there should be a line for this.
Line.
Yeah, there's a line. Yeah, you can see it's sitting on. It's not exactly. There's a small error. Yeah, it's sitting nearby that.
Okay.
Yeah. So our values are not perfect. You can see it's little bit away. See.
I see.
Yeah, it could be due to calculation errors. But if we take more points, our then average will be better. Okay. Then the next one is a point to construct. Okay, this is for testing point. Okay, so but now these all the points are we know. For example, for point number 2, we already know the position of point number 2. This is the data we used to construct. So now we will give a new point somewhere else, and since we have the F matrix, we'll try to construct the same, because F matrix is constructed with these points by giving this data, by giving these 15 points. So we'll try to give totally new value, and we'll see whether we get a value, how it is doing. You can see it. So we construct one new point in the p-test. Let's see, should be in the left image. Yeah, we can see we took one point. It's called p-test. It's exactly on this position. And other side, we should get a line now. Still, I didn't run the code. I will not get anything until then I will run all of these. Yeah, now I should get a line in here. See, we had our p-test point in here, and our line, it's going exactly on the correct place. So if we search across this line, we can find the point. Best match. Okay, you guys got it?
Yes.
Okay. Now find the epipole. Find the epipole for the left side is easy. So for the left side epipole, so how to take the epipole? If we have a F matrix, we directly take the SVD, and the last column of V, it is our epipole. Why? What is this? It's a big matrix. F is a big matrix. And what is CE? It's a vector, long vector. What is this vector? It's column, row, and 1 coordinates of what? Of epipole. Okay? Equal to 0. If a big matrix multiplied with a vector equals 0, this is our homogeneous equation. Then this can be solved with SVD. Okay, got it? I need a yes or no.
Yep.
Yes.
Yeah, so we can use SVD to solve this. The last column of V is our epipole. So in here, why we didn't take SVD here? Because above step, we already took the SVD of F. See in here, I can show you guys. In here, we already took the SVD of F. And the V value, we call it as VF. It's already there. VF is already there. So the last column of VF is our epipole. Okay. And you can see where's the epipole now. We said all the epipolar lines should go through epipole. But you can see it's not going through one point in here. If you look at carefully, yeah, it should go through one point, but it's not going through, right? So let's see where the epipole is. And when we see the epipole, we get these coordinates. Okay. By the way, this is in millimeters. So this is in pixel. Yeah, this is in pixel because F is in pixel. F is in pixel, so this is in pixel. Can you tell me how far is the X value? In our image, we have three values. This is image X. So this is our image column, the number of columns, and this number of rows. And the third one should be the depth, which is 1. In here, when we see the epipole, we can see we need to multiply. EL, just type EL here. Yeah. Okay. The values for epipole, it should be comes in column, row, and 1. And we are getting 0.001. Then all the values, we know the last value should be 1, and we are getting this value. That means we need to multiply everything with 1000. When you multiply everything with 1000, what's the value you get in here? 9,979. Okay, that's mean it says in the minus direction. Our epipole is 9,979 pixels on the minus direction. Our image has how many pixels? This is 768 pixels.
68,
Yeah, it's so much far away. It's long away. Is our people away from the image. It's not inside the image. It's so much away. That's why we can see all the lines are parallel. It's actually not parallel. It should be tilted on this side. It should be, shrinking on this side. So we'll see in the image whether we can see that pattern. In the left image, yeah. Okay, this is the image. We'll keep it. It should be shrinking on this side. It should be shrinking on this side. Yeah, it should be shrinking a very small way because it's so much far away. Okay, because this is our 0th pixel and this is a 768 pixel, but that is in minus direction, 9,900 something big number. Okay, and right side, yeah, in the right side also we can do the same and find the right epipole, right image. Then again we need to take the F. So we'll see how to take it. It says we need to take the transpose of F and then we need to solve it with SVD. But if you take the SVD of F one time, transpose of F SVD, so SVD transpose of F, that is equivalent to VSU. These two values are positions are changed. That's it. If you take the transpose. Okay. So we took the SVD one time. So we don't have to take transpose and do it again. So we can directly take the last column of U. Got it? Nima, you got it?
Yeah, got it.
Okay. So that's why in here, we take the last column of UF to find the right epipole. And you can see this value again. I will just go how much far away. It should be again 9,991 in the plus side. So the right image epipole should be somewhere far away on this side. Okay. So I just divided these values by the third dimension. So you can see the, if I check ER now. Yeah, you multiply this by the, because now it's in scientific format. But you got the idea, right? Yeah. Okay, that's it. That's the end of the lab.
Okay.
So I will stop recording.